So that's what we have seen in setting up and getting started. Then in the first section, we have covered Terraform with Docker and ACI. And then in the second section, we started off with the NSO. And as part of NSO, Cisco NSO Network Services Orchestrator, we had seen how we can automate some of the network configuration and network provisioning stuff using Cisco's NSO. In this class, we'll see the core concept. As the name says, Network Services Orchestrator. We'll see what is a service and how it can be used to automate some of your configuration efforts. And at the bottom of it all, we have Yang, which is a data modeling language, data modeling standard that is being used. So we'll go and get into some details with respect to Yang. Okay. So as for you to practice, either you can download and install NSO, for which the instructions are given here, or you can simply use Cisco's Developer labs on developer.cisco.com. Right, they've done a pretty good job with the stuff. Right, so you can use either of them. Okay, what is NSO? How does it work? We have already covered how to install it. And how to do the basic configuration. So before jumping in, we'll just see. Okay, a lot of people are finding voice as low. Where is this link? My voice is little low. Voice can be increased. How is it now? My voice? Okay. One or two saying it's fine. Probably you guys can. I mean, I cannot increase the volume of input. You can certainly increase the output volume. Yes, this doc will be shared. It's already, I mean, as and when we make any updates, yeah, you'll have to increase the volume on your side. Yeah, yes, this document will be shared. So okay. Okay, so this is so this NSO is my installation directory. Now NSO works slightly different, right? Because NSO has to do with network device configuration automation. So for one project, you might have one set of devices. For the other project, you might have other set of devices. So you cannot have one central location from where everything runs, because NSO stores the configuration inside its working folder. Inside the NSO's working folders, it stores the configuration in the form of a database called as CDB, configuration database, in its own proprietary format. So how it works is the installed location of NSO is different from the running instances of NSO, right? So there is a NSO software which is installed, and then if you want to work on project one, you can create one instance of NSO and work inside it. Similar to this, you can create any number of running instances of NSO. You can think of it, if you're familiar with Python, there is a concept called as virtual environments. For project one, let's say you are using certain version of Python, certain version of dependent libraries, you will create one virtual environment. If you're working on another project, you'll create another virtual environment. So that way. Same is the case for Ansible as well. Right? If you're familiar with Ansible, Ansible is nothing but it has an inventory of devices using which it tries to configure. Right? So for project one, let's say we have one set of devices, we put them we put that Ansible config file and Ansible inventory file in one folder. And for project two, we create another folder, we put inventory file, we put config file, and work in it. Same is the case here, right? So you have a main installation folder, which is called as NSO, and the working instances you can create anywhere, right? But to be able to do that, the NSO commands, right, which starts with NCS, right? All the commands start with NCS because NCS was the older name for NSO. So all the commands that are used for, let's say, starting the simulated devices, starting NSO, stopping NSO, etc., etc. All those commands need to be identified on the system. So which means it has to be added to the path. So inside the installation folder, ls NSO, we have NCSRC, which contains which needs to be put on the path so that all the commands are available for us from anywhere, from any folder. So either we can add this call source NCSRC to bash profile, so that every time our system restarts, this file gets called and the commands are available for us. Or if you do not want to do that, whenever you start working with this thing, you call this file. Okay. So this is my installation folder. I'll not spoil my installation folder. I'll leave it as it is. I created a folder called as work. Inside it, I have a couple of instances. So I'll create one more. This I'll use as my work directory, where I'll be trying to set up one running instance of NSO and do whatever work I want with it. So this you'll get used to it once you start working with NSO. Okay. So I've explained all these commands. CD, you have a work folder, CD work. Then you can create one more. You can change to that folder. You ignore this step, I'll be removing it. Now, first step that we'll do is in a real life scenario, you will have your real network devices, which are reachable via telnet, SSH, etc. So you can tell your NSO to connect to them and then read its configuration. Here, we do not have network devices for in our development environment, so we'll be using NetSim, Network Simulator, which comes pre-installed with NSO. to create the devices. And what type of devices? We said that NSO is a multi-vendor platform, which means it can work with multiple device types. So by default, they added support for few of the device types, but in the form of network element drivers, NEDs, which they have given along with the installation. In addition, we can download and add new NEDs, and we can also develop if there are instructions given on the Cisco site. If you want to develop your own NED for a new device which is not yet supported by NSO, we can do that as well. So they have given you a lot of flexibility. So currently my work folder is empty. I'll create a simple using this netsim command. I'm creating a simple network with two devices of this type. This is my NED, right? Which means I need to I think it identifies by default. It goes to NSO folder, and I'm creating them inside a folder called as iOS. I'll be sharing the workbook. Workbook contains instructions on how to access the VM. Okay. So what we have done is we have created sample devices for us to work with this thing, NSO. To an LS, a folder called netsim is created. Inside netsim, a folder called iOS is created because we said we gave this path. Inside iOS, it placed two more folders, iOS 0, iOS 1, because I asked it to create two devices of this type. So it named them as iOS 0 and iOS 1. So two devices have been created of this type. Okay. After I create my devices, I need to create a running instance of NSO. So I'm telling NCS setup is the command which is used for that, right? So in this folder, I'm creating a running instance of NSO using this command. I'm giving destination as current folder, right? NCS setup --dest dot. Where to create that running instance? In the current folder. And where are your devices located? --netsim dir netsim, which is there in the current folder itself. Right? That's the reason we created the devices here, and we are setting it up. Now you see some files have been created, some scripts, packages, CDB, configuration database, all configuration file, all those files are created because it has been set up. Now we need to start the network devices, right? We created the devices, we created NSO instance. Now we need to start the devices, start NSO. NCS netsim start is the command. Okay, my devices are already running. First I'll stop them and then start. They are created in another folder. They are running. Now I'm running the current instances. Okay, you will not be getting this issue because you'll be starting it afresh. And then I'll also start my NCS service, daemon. We call this as daemons, so that they are running in the background, always listening to our requests. Yes, while creating NEDs come, few NEDs come pre-installed with the installation folder, right? CD /NSO. Sorry. Ls packages, NEDs. So all these NEDs have been pre-installed for us when we installed. Out of that, I use this NED to create my devices, because I used this name when I used the NCS netsim command to create a network. Okay, NCS is also running. That's why it is giving NCS. So we can think of these NEDs, network element drivers, as your providers, or in Terraform, we have seen the concept of providers. In Ansible, if you're familiar with Ansible, there's a concept called as modules. In Python, we have the concept of third-party libraries. Right? So some additional pieces of software which will help you to interact with other devices. Okay, NCS is started. Yeah, that's a technical definition, but I was trying to put some things into perspective for a person who might find it difficult to understand in comparison. Okay, so now we need to, this is the command to get into the command line of NSO. NCS CLI is the tool used. -U admin, connect as user admin. -C, it stands for, okay, present me Cisco type interface. The other alternative is Juniper type interface. Okay, we connected. Now we want to, this is the command which can be used to tell an NSO to learn the configuration of the devices and pull it and push it into the CDB configuration database. Okay, basically northbound, southbound come into picture when we have something like a management layer, right? You have a management software, so which sits in between, in the middle. So below the if you try to visualize it, right? Management layer sits in between. Below the management layer, you have the devices. Above the management layer, you have applications, right? So northbound APIs are those APIs that provide communication between your manager and your applications, which means you move up from the management layer, you access up the things which are above, right? So those are the northbound APIs. Southbound APIs are like from the management layer, how do you connect to the devices which are in the layer below? So that is the terminology used. Okay, my devices have been synced with, which means the CDB has been populated with the devices. These parts we have seen last time, how to configure the devices, how to. So we'll jump to the service, creating a service. So basically network services, right? Network services are like some tasks which some configuration tasks, right? Like configuring VPN, creating ACL lists. So this kind of configuration tasks can be defined as a single unit called as service. Why this is done is so that we can talk at an abstract level. We can just use the service to perform all the tasks by hiding the details inside it. And since we are planning to automate, once we have these services, we can call these from other automation tools. You can write a Python script, you can use them in Ansible playbooks, you can use your netconf protocol or RESTconf, use them as REST APIs, etc., etc. Right? A lot of automation can be done. That is one advantage. The other advantage is it makes things abstract, and you can define in one common language, which will be translated by your NEDs into different devices. Right? You have devices of different manufacturers. You don't want to. So far, with the manual configuration, you have been doing that. You get into CLI of each of those devices and give vendor-specific CLI commands to configure. That's what we are trying to move away from by moving in towards network programmability, network automation. So this services is another layer on top, another layer on top of it. So we create a service model. Based on the service model, we create a service. Into that service, we pack whatever configuration that we want to do. And then we can start using this service to do the job for us. That's what a service is. Service is way of simplifying device configuration by automating provisioning in NSO. To add a service, you need to create a service package, right? This is NSO's internal stuff, right? The NEDs and the services are packaged into objects called as packages. That's what the folder that we had seen in NSO installation folder. There's a directory called as packages, inside which the NEDs have been placed. So somewhat similar concept is going to be applied for service as well. We'll be creating a service inside a package. To add a service, you need to create a service package which will have some pre-built files and directories. We'll use the NSO's built-in command called as ncs-make-package with option service skeleton to create a blank service. Now we want to create a blank service and then modify it to do I mean, I don't know anything about creating how a service looks like. How do I start? Where do I start? How do I go about creating a service? Right. So what these guys have done is they have simplified your task by giving a command which can create a blank template for you, which says that how your service should look like. Okay. Currently, I am in my system. Okay, I'm inside the CLI. I'll get out. So I'm here. This is my my running instance. I'll check in packages. As of now, I only have this NAD because this is the NAD based on which I created my network. So I do not have any services yet. So this is where I'll use the command to create a blank service. I'll do cd packages and then use this command. In my running instance, in my NCS runtime instance, I move to a directory called packages and then I give, I give this command ncs-make-package. Now what kind of, so there's a command to make a package. So you can make two kinds of packages. One is NAD package and the other is service package. Here I'm interested in creating a service package. So I'm saying ncs-make-package -- service-skeleton, right? So you should use service skeleton called as template. So use the service skeleton template and name the service as simple service. To ls, we have simple service. ls simple service. This is the standard structure of a service. There is a metadata XML file, there's a source folder, there's a templates folder, there's a test folder, which can be used where you can put some code to do the testing for this service. So, but these are the main folders, source and templates. Now, source and templates. So let's check source. There's something called as a makefile. I'll explain what is a makefile, and then a folder called as yang. Let's check what is in yang. So there's a, with the same name as the service, there's a yang file, .yang file, which is created. Simple service.yang. Okay, we'll leave at that. We'll leave it at that, and then we'll check what is there in templates. ls simple service. So with the name simple service -template.xml. So there's a yang file, there's a XML file which is created. So basically NSO service consists of these two main pieces. What is NSO service again? An abstraction or an automation of network configuration. So when you are trying to configure the when you are trying to define how to configure multiple devices in multiple devices of multiple manufacturers using a common terminology, we need to define that common terminology, right? We need to define one uniform set of terms, which is what Yang is used for. Yang is a data modeling language. What is data modeling? How it is used, we'll see in the next section. But for now, we'll quickly understand that. Okay, we'll be defining that common terminology in Yang file. Now, based on what we define, which means YANG file talks about how your configuration should look. What are the valid values which are allowed to be put into your configuration? That's what we'll define in YANG. Then based on this YANG, we create a XML file which contains the actual configuration defined in a XML format. Now this XML format is taken by your NSO, converted, and it is handed over to your NEDs. Suppose in this case, I only have one NED based on which, which needs to interact with my iOS devices. So this service definition, which is in the form of XML template, is given to this. This guy knows how to convert this XML into device-specific commands, iOS commands. Same way, if I had Juniper or Dell or Arista, some other NEDs, the same set of instructions will be given to all these NEDs in the same format. Now, it is the headache of these NEDs to take these instructions, translate into the respective underlying device formats, and go and execute the commands there. You can create anywhere. You can create outside also, MyNSO2 also, but service ideally, I would like to keep it inside my packages so that it's neatly organized. Purpose of YANG file is to define how your configuration should look. What all should be there in when you are defining the configuration in a. I'll show you the structure, then we'll understand better. But I didn't want to get into details. Still, you understand how this happens. You define how your configuration will look using YANG. You translate what is defined in YANG into actual values in using this XML configuration. This XML is then given to all the NEDs. All the NEDs will take this XML and translate them into the corresponding device-specific configuration commands, go and execute those commands on those devices. So that's how this entire pieces fall into place to solve the puzzle. Yeah, there is a lot more explanation on YANG coming up. Not exactly the same, but yes, in a way we can relate them. Relate the NEDs in NSO to providers in Terraform, because Terraform also is like a enabler, right? Terraform by itself cannot do anything, right? Like Terraform can be used to provision AWS machines, Azure machines, Cisco ACI resources, right? How will Terraform do all these things? So it uses these providers, right? AWS provider, Azure provider, Cisco ACI provider. So it just gives those instructions. Okay, go and create this resource in this, right? It is the providers will take care of doing that. So in that sense, I am trying to compare NEDs so that we can understand them better. NEDs are like your agents, which knows how to talk to me in English and how to talk to the underlying machine in its language, right? So that's what is NEDs. Purpose of service template, everything, we'll see everything. Yes, NEDs need to be specifically let's see how this YANG file looks like. Again, we are directly jumping in, and then we'll see how that YANG file gets built. Yes. I'll get inside the service folder. cp simple service ls src YANG. So what this file is defining is, it's defining a simple service. This is the name it comes from. You ignore this namespace import pieces for now. Then it is saying this module is like your you write an Ansible playbook, right? Or you write a Python file. So it's like that. In Yang, we the high level thing is, we call it as module. Now, when you go inside it, what we are actually defining is a simple service. Now, I can define more than one service. So it is not one simple service. It becomes a list, right? This is a Yang's notation. What does this mean? We'll again come to that later, right? So we are creating a list of, using this definition, we can create a list of simple services. Now, key name means that each of these services will be identified by their name. They will have a field called as name, and that name is what will be used as a key to uniquely identify. How you can think of this key as, you would be familiar with databases, right? Database will have tables. In table we have data in rows. So to uniquely identify each row, you have something called as a key, primary key, which will be like, let's say you have a bunch of employees records lying in the table. Employee ID will be a field or column using which you can uniquely identify each employee. So key is something like that. Using name field, you can uniquely identify service, distinguish one service from the other. Then I'm talking about what exactly is inside my service. So each service will have a name and a list of devices. A name and a list of devices. What is the structure? Again, we'll come to that. But these are you can ignore all these pieces. This is where the actual service definition starts. We are defining a list called as simple service, which means you will have more than one service. Now, how can you uniquely identify each service? Using a service's name, which means the service should have a name. So I'm saying that the service will have 2 leaves minimum. Now these leaves, right? Leaf. These leaves are what will be there in the service. So the service is made up of a name, a device, and some other configuration. At the bare minimum, what am I trying to do? I'm trying to define a service to configure a device. So I need a name so that I can identify I can uniquely identify that service, and device on which I'm trying to apply configuration through this service. So these two are like bare minimum fields which should be there in the service. After that, I can put any number of since I asked it to create a dummy template, so they just created a dummy template and then said you can replace this with any configuration that you need. So let's say I'm setting a host name. I want to set the host name of certain devices. So I'll define this as leaf host name. I want to, let's say, set the password. I'll set this as leaf password. Let's say I want to do something to do with the interfaces. So I'll define leaf interfaces. So that's what is data model. Now to put it in even simpler terms, data model. Okay, we'll come to this, right? Okay, for now you understand that. Okay, this guy here is defining that yes, your simple service will consist of a name, which happens to be a string, device, which is defined using the devices which we just created outside, right? Which are under which belong to NSO's device. Each device can be uniquely identified using this path: devices, device, name. Okay, and any other configuration that we want to put, that we will be defining it here. So this is how Yang looks. Then we'll look at template. So since again this is a template, it starts with the structure will be same, right? Config template. Inside that you will have devices. There can be more than one device because you can configure multiple devices in single shot. So devices, inside devices you will have each device. Inside each device will be uniquely identified by its name. So this is like a reference, like a placeholder. Where will this come from? When I use the service and pass a service name to it, that name will be substituted here. If I'm calling this after, assume that the service has been created and I'm calling this service for configuring device iOS 0, that iOS 0 will be substituted. So that's how device identification will be done. And then this is the config field where you actually place your configuration stuff. We'll see one simple configuration from Cisco example. So this is the template. Now this dummy part will replace with this guy. Leave secret, which is of type string, which means secret means password. So I'll be creating the service to enable password on the network devices. And that's what my service will be doing. The service will be enabling the password on the device. So I'll go back to my Yang file. I'll not change any of this because the service needs a name. It needs to identify the device, but only I'll change the dummy part. I'm defining something called as secret, which I'm saying it happens to be of type string. And obviously, password is a string. Right? You can use this one instance to configure 10 devices. Because we are defining one service with one device, you can use the same service to configure all your 10 devices. So let's say on device 1, you want to apply secret 1, you pass device 1, secret 1. Not here. This is like I'm just defining what my service will contain. And then we have to change the XML template, right, by putting the configuration. So this is my default code which is generated, that I'll change with this. Okay. Config template, devices, device name, config. What is the configuration that I'm doing? Enable. I'm enabling what? Password. I'm enabling password on the device. Now, how to write this? We have to take, we have to use the documentation to create these templates, right? Because these are not like programming or scripting where we have the generic tools. There's a way to do it. There's a way to do it. So there's a bit of learning here, which is involved to be able to build these configuration templates. Enable, we are enabling password. The value for this password will come from secret, which is defined in your YANG file. So your YANG file defined the device, which is this is the device that you're trying to configure. The configuration that you're trying to do is enabling password. So this secret is what is defined in your YANG. So that's the link between your YANG and this configuration template. Now, there the type of secret is given as string, which means if you're trying to set anything other than string here, it'll throw an error. And there I can also put some restrictions. Your string has to be like, let's say, minimum 10 characters inside. So if you're trying to, while configuring the service, if you try to set the password to less than 10 characters, it will throw an error saying it is violating the rule which you have defined in the YANG model. Yes, that's another way. You can configure this thing and then extract the XML from configuration. Okay, so we modified our YANG template, YANG file, and the service template. Now, whenever we make any changes to YANG file, right? We have to compile it. We have to validate that those changes are not violating the syntax rules, or we have not made any typos or mistakes while editing the file. So we'll be validating all that and building it so that your NSO can take this YANG module and apply it. So for that purpose, this make file is given. That is the purpose of this make file. This is actually a shell script. So if you are interested, you can go inside and see what is written. If not, you can simply say make and point to your, I'm here. So I have to say src /. Inside my src, I have this make file. And so when I said make file, say src, it goes inside, finds that make file, takes the instructions from that, and it has validated it. No issues, right? No issues found. So it is saying, yeah, everything seems to be fine. I'm leaving the directory, entering the directory, doing the stuff, and then leaving the directory. It is building something in between, making make dir -b created some load directory, and then it did some things. So it has kind of compile the package. Now I need to reload this package from your NCS CLI. I'll go there, NCS underscore CLI. See packages reload. Right? These are commands we have to get used to it whenever. But if you're working with NSO, you'll get used to this pretty quickly. Whenever we make any changes to our, let's say we added a new NAD, which is there in the package, or you created a new service inside a package, or you changed an existing NAD or changed an existing service. So your package has changed, which means you need to run the make command in case you have changed the Yang source. And you need to reload the packages so that whatever changes you have made, they will take place. They will take effect. So packages reload is the command which does that. So there are two packages basically, right? The NAD package and the simple service package. So the simple service that we created now has been identified as a package, and it has been loaded into the system without any issues. So we are getting load result as true. Now our service is ready to be used. So before that, we can there's one more command like show packages package operating status. So with no errors, it says, yeah, both are up and running. Better to be at the, I mean, you say packages reload, it will reload everything, it will recompile everything. I mean, if you have too many, then probably you can choose and check the command if there is a way to do that. Okay, so if you have made any mistakes, right, it will point out like this. So let's say you missed out a curly brace or something like that. It will highlight the line number and then gives an error so that you can go there, find out what happened, rectify it, and then come back and compile it. Okay, so now our this thing is service is compiled. Another way you can check is there's a Python module called as Pyang. I think I showed you last time, right? You can use that. It's also pre-installed with NSO. So you can use that to check the Yang in a tree structure. Packages are up and running. Yeah. Now our service is ready to be used for configuration. Okay? So you type sim, it's identified because your package is loaded. It's been compiled and properly loaded. Simple service. Now you don't know what to do with this, right? You put a question mark, just like how you. So as per the Yang definition, right, every service will have a name. So we give a name to it. And then tell which device that you want to change. let's say I want to call this service as PWD change service. Let's check. Okay, sorry. I need to be in config mode because I'm making changes using this service. I'm making config changes, right? So I need to be inside the config mode. Now it's a simple service. Put a question mark. It says yes. Possible completion. Say you need to give a name, which happens to be a string. Right? So I give a name. And then put a question mark. So it shows one of the options. So these are all options. These are all default options which came with the Yang model, but this is the one which we added, right? Device. So we give what is the device that we are planning to change. We say iOS 0 or 1. Okay. So you see, as per the Yang model that we have defined, the service needs a name. So we have given a name. It needs a device, right? On which it is making the configuration changes. So we are giving it a device. This device will go, and in the XML configuration we had that device placeholder, right? It will go and sit there. And then what is it that we are trying to change? What is the configuration change? Enabling a secret. So we need to pass the secret. Which again is a string. So I'll be passing my password as a string. So this is how you invoke a service. So this is how NSO shows. It keeps changing the prompt whenever we give any this thing, because we created a simple service and called it as, it has got into this prompt where it has named it as this. Come to the parent context using prompt. Now I made a configuration change via my service, but I have not yet pushed the changes. So meanwhile, you can change. Till you push, you can change. I mean, before pushing, you can validate your changes by using show configuration command. So if you give this command show configuration, while still being in the config mode, in the parent context, it will show on device iOS 0, a secret called as my password has been set. So you see this device is being shown as a list notation because in the config, right, the devices inside the device was there. So there can be multiple devices. Okay. So this is the configuration change that I've made through this service by invoking this service and passing the required values. Now I'll say commit. Dry run or commit. Dry run is like, again, another level of check before pushing. That completes the service definition and using it to change the password. Now let's say you want to reset the password. Right? Reset the password. You need to do this. We have some additional methods like get modifications. So it is saying, I mean, I changed my service. Previously, my service was created. Now I changed it by changing the value. So what is the change that I made? I just changed the password which I'm storing in this secret, which means my data has changed, right? Not the definition, not the structure, nothing of that has changed. Only the data has changed. So it is saying local node data is what has changed when I asked it to show get modifications. Then I can redeploy this service using redeploy command. So redeploy also does committed the change. Yes, name can be anything. Yes, commit try run is like, yeah, check. Ansible has check mode. Terraform has that plan. Similar to that. If you change the name while changing the password, it becomes another service. Right? You're not changing the same service. You are creating another service. If you want to delete this particular service instance called as test1, you can say no simple service test1. Only this instance of the service will be deleted. You can always create again another service using this. Okay. So that's what the S part of NSO, Network Services Orchestrator. Here it is a simple service. We can always make it complex one. So you can explore Cisco's documentation. You can define multiple values which are being changed and so on. So let's discuss what is Yang. Yeah, I'll be sharing it after the class. Okay. So basically, Yang is a data modeling language. Right? Data model means, yeah, there is an application, you need to pass some data to it. How you structure your data. Right? For example, like you want to define a person, right? You are describing an organization. You want to describe its employee, right? Employee happens to be a person. So how you will define that person? What are the attributes the person should have? What are the characteristics that person will have? Right? He can have many, but in this context, what defines a person? Right? Suppose we are talking about a person within an organization. So he'll have first name, last name, date of birth, job role, email. Let's say the same person he's ill, he has to get admitted in hospital. Right? So his details will be different. Right? His patient ID, his health history, all those will define that person. So there the data model of this person changes, right? So depending on the context, depending on the application, depending on the situation, how we model the data differs. In this context, these are the details which I require for me to define a person. So these values become my data model. Attributes. These are the attributes which can define a person. Now, how will I represent this using, let's say, Yang? Right? So since I can have, I'm defining a generic person, like this I can define any number of persons. First thing, that person is going to be a list. Right? So I'll define, these are like types in Yang. Right? My person will be of type list, which means list, we call this as nodes. If person is going to be a list node, because there can be more than one person. I can use the same model to define more than one person. Now, when I can define more than one person, how will I uniquely identify each person? Obviously, it cannot be first name and last name, right? Because there can be many people with same first names and last names. So what we'll do is we'll use email, because typically email will be unique to the person. It has to be. Then I start defining, how will I be defining my person? So the person will have first name. Right? Now this first name will cannot be further broken down. There will be a string which will be stored in the first name. So the type of this node becomes leaf. Right? So the leaves in the nodes, these are called as nodes. Node, you can think of Yang node as a data structure in other like programming languages. In Python, we have tuples, lists, dictionaries. So here we'll have nodes. The nodes can be of different types, like a list node, reference node, or leaf node. Leaf node is like primitive, the smallest unit, into which you simply store a string or integer or boolean. Right? The other ones are like complex, which means inside these you can have multiple values. So for example, a person cannot be defined with just one value, right? He needs a first name, he needs a last name. So this is like a complex node. Inside this, you will have a leaf node, which is first name, then another leaf node, last name, another leaf node, date of birth, another leaf node, email, and finally, last leaf node, job role. Right? So whatever details that we need to define a person, we define those many leaves. Person will have a leaf node called as first name, last name, date of birth, email, and job role. So that's the first thing that we need to do, right? Identify the complex object and what are the leaves or attributes which will define that. Now get to each leaf level, right? We need to define for each level. We need to define what type of data it is going to contain using the type attribute. Right? For example, first name is string text. Right? So we define it this way: type string. Then first name, we can also say whether it is mandatory or not by setting this mandatory to true. By default, if you do not specify, it becomes false. Right? We don't need to pass this value. But since we put it as mandatory true, wherever we are using this, right, first name becomes mandatory. Then this is like adding some description. This will not affect your end result. This is just for, these are like adding comments in programming language, right? You add comments. So this is like you are adding some description. Now that this tailf is like a company which has created this AI. Now it is bought by Cisco. tailf is a Cisco company now. They defined this info. Right? They called this, they said that, yeah, if you want to pass some comments or if you want to add some description with each node, you need to use an element called as info. But this info comes from tailf. So they put tailf : info. So this is just like a text that you can add. This is not mandatory. Even if you skip this, nothing will happen. So a person's first name is of type string, and it is mandatory, which means it has to be used. It has to be passed wherever we are dealing with that person. Then same way, last name is of type string, mandatory true. Date of birth, right? Date of birth is also a string, but it cannot be like any other, like it cannot be 1, 2, 3, 4, right? It has to follow certain pattern. So data model can also help you to apply that restriction. How your date of birth should be specified. It should be specified as 2 numbers slash 2 more numbers slash 4 numbers. It is like DD, MM, YYYY. Right? That's another thing Yang will help you to do. Yang will help you to define which all attributes should be there, what should be the type of each of those attributes, whether they are strings, numbers, etc., and what pattern should that, and whether it is mandatory or not, and what pattern should that field allow the data to be passed in. In this case, date of birth should be passed as a DD, MM, YYYY, which means you cannot pass it as 3/6/1980 or something like that. Right? It has to be 03/06/1981 or whatever. Now email, here they have they're taking the type as string and mandatory to true to keep it simple. But otherwise, there's a lot of validation that can be done on email, right? That it should have at least 8 or not more than 8 characters. Then it should have an @, then it should start with 2 or 3 letters of the company. Then it should have a dot, and finally it should have 2, 3 letters like com or org or something. So there are we can put that in the form of regular expression here. We can define the regular expression which will be used to validate email and specify that in this pattern. So this is also in a way regular expression. Then that email will be validated to ensure that yes, whether it is meeting that the standard which is set by regular expression or not. Okay. Job role. Now this is a different data type. In this organization, there are only 3 types of job roles. One is admin, second one is developer, third one is manager. Which means any employee will be falling into one of these categories. Either he is an admin, or he is a developer, or he is a manager. There are no other roles, right, in this strange company for whatever reason. So to define this kind of type, to define this kind of data, we use a type called as enumeration. We are listing. Enumeration means spelling them out, listing them. So job role must be one of these things. Enum, admin, developer, manager. If you give anything other than this, validation will fail. Okay. Does that put at least some perspective around what is Yang, how we go about defining it, how we can use it to define these things? Data models form the foundation of model-driven APIs and network programmability. Right nowadays, we are talking a lot about network programmability, and then everywhere we have these APIs. Now, when we have an API need the data to be sent in certain format. When you are using protocols like netcon, presscon to push automation to devices, they need to send that message in certain specific format. So to define that specific format in a uniform way, we use Yang. Okay. So they define the syntax. They define the syntax, semantics, and constraints of the data which is interchanged. So that's what the constraints that we have seen, right? One sample constraint was applied on the date of birth. Okay. Now let's take another example. Right? Let's say you are defining some network configuration. So you are defining some VLAN related configuration. So these are the questions that you'll be adding, right? What is the range of valid VLAN ID? Can you allow any value to be entered, or you want to restrict it? Can VLAN name have white spaces in it? When someone is sending that VLAN data, can you name VLAN like VLAN space 1? Is it valid or not? Should the values have enumerated and only support up or down for an admin state? Right? VLAN will have an ID, VLAN will have a name. So the constraint to be applied, the decision to be taken for VLAN ID is there a valid range? For name, should it have spaces? For admin state, can I allow anything, or should I restrict it only to 2 values? Because admin state can either be up or it can be down. It cannot be one other than this. Right? So should I restrict this, or I'll just leave it open? If I leave it open, someone will say yes, it is up, instead of saying simply up. Right? Someone else will say yeah. So we want to restrict such things. So we'll say yes, it is going to be enumerated type where only it will allow up or down. Should the value be a string or integer? So this kind of to answer this kind of questions in a uniform way, we define YANG data model. Right? So every YANG data model starts with a module. Right? Here we are defining a fresh data model. So it starts with module. The name, what we are defining here, is typically the name of module. IETF interfaces. IETF is the standard, right? Which says how your IP addressing should look like, etc. So I'm defining data model for IETF interfaces. Now, these import statements, it's like just like how I am defining something here, someone else has defined something elsewhere. So instead of reinventing the wheel, I want to borrow what others have defined, what other data model, like let's say there's a complex data structure. Cisco has already defined, okay, if you are using BGP related configuration, this is how it should be defined. So they have already defined in one YANG model. Okay? So instead of again me defining all those things, what I can do is I can simply say import whatever that they would have exposed it publicly. Right? So same way, I am borrowing types, YANG types to define different things. So I am importing it. Then when I import it, I'll get a bunch of names. So those names I'll be using with a prefix called as YANG. So that's the meaning of this import and prefix. If you are defining a YANG module where it's a complex type where you are borrowing someone else's YANG module which has been defined, you say import. And now you are using some set of names like interface, description, and some names will be coming from the imported stuff also. So to avoid this confusion, you say that the guy whom I am importing, they will be prefixed with this YANG, so that there's no confusion. Let's say this guy also is defining interfaces. Then that will be YANG : interfaces. Mine will be simply interfaces. That's the meaning of this prefix. Version is not mandatory, but yeah, I've put it down. I mean, I'm gradually building it. Okay. So module, I give some name, then any import statements, then this is like a complex data type, right? Interfaces, you are defining interfaces. There can be multiple interfaces in it. So you define something called as a container. Inside that, as I said, like interface is going to be the actual, which will define the interface. So which is a list. That list will have a key, which can be using which you can uniquely identify. So key is a name. Then there's the leaf name, which is of type string. So there can be some description associated with it. Then your interface will have a name, it has a description. So leaf description, which is of type string. Then your interface will also have a type, right? Leaf type. Its type is identify ref. It is coming from somewhere else, right? Base. Base means it must be coming from here, which is mandatory. And finally, the interface. Whether how do we define whether this interface is enabled or not? So it is of type Boolean, true, false, and default. We can also define by default it will be true. So we treat every interface as by default enabled. Okay. So same thing I've explained with another example, which is like access list. So we can have name, prefix, and then we can add some metadata, right? So these are again like optional fields. We can either skip or we can add it. So typically it's a good practice. Like you're defining a YANG module for your entire organization, right, which you plan to share, or you plan to share it with customers, or you plan to commercialize it, productize it, and give it to your customers. So in that case, this information makes sense. Like which is the organization which has created this, whom to contact, and what is it defining, and what is the revision. Because today I have defined it, and I'm calling it as initial revision. Tomorrow there's a better way to represent something, and so I'll modify mine. So I'll give some other revision number and describe like, okay, something else has changed, that's why I'm changing my model. So to keep track of these things, which organization, who is the contact point, what am I building in this YANG model, and which division is it? Because I'm creating and declaring a document. So it is like that. To maintain the sanctity of the document, I need to define all these things. Then we have already seen like what are containers, what are leaves. So container ACL can have a description, and then it will have leaves. So these are two more restrictions. Like now leaf ACL description. Its type is string. So we are saying ACL description should be of certain length. So its length can be between 0 and 64, not beyond that. And then it should follow certain pattern, which is like digits, lowercase letters, uppercase letters, repeating any number of times. So this is known as a regular expression. Saying that, yeah, that ACL description will be a combination of numbers, lowercase letters, and uppercase letters. Star says, yeah, any number of occurrences. Now, just like how we had list outside, right? Uh, let's say we have complex elements like list of persons, list of interfaces. So we define it as list. Now we go inside that and we are talking at the level of leaves. Like let's say uh, hobbies. We were defining a person, right? Person's hobbies. We want to incorporate person's hobbies into the data model. So we go inside and we define, because we'll have more than one hobby, we'll define all those as leaf list, list of leaves. What I'm basically defining is a leaf, but it can contain more than one value. So hobbies, leaf list hobbies. So hobbies will be like playing this, playing that, doing this, going there, all those will. So these are different node types: leaf list, list, container, module. Well, someone should have defined it either on the GitHub project or something where they would have defined the namespace. So you need to say import that name, point to that namespace. Okay. Finally, something about the final data type. We have been seeing type everywhere, right? Type string, uh, type boolean is what we have seen. But not just those, it supports these many these things. Fix, boolean, decimal, empty, enumeration, identify ref, a reference to an abstract entity, numbers in 16, in 62, in 32, in 64. Then uints, unsigned integer, which means there can be negative values also here. Okay, so your data in your leaf nodes can be of any of these types. Okay. Now this is the example of enumeration. Let's say we want to set something as true false. Right? We use enumeration with these two values. Or you want to identify whether something is enabled or not. So enabled, disabled, you put to enumerate two values in the enumeration. So, or you want to define the type of IP address, IPv4 or IPv6, because only these two values are possible as a term. Right? So you just make them as enumerated data type. Anything other than this will not be accepted. Okay, that is kind of Yang. Where is it useful? We have just seen, right, while defining a service. It can be used in many places. Right? Even on NSO, we can define a Yang model, put it in a certain location, make it as in the packages. We can put this, place this, and then make your reload your packages again. Then whatever you defined in the Yang package can be used as a Yang file, can be used as a command line command with the attributes. We had seen that person first name, last name, so we can put that in that packages folder in a Yang file, and then when we start typing person, right, person, and then put question mark, it will prompt. Okay, if it looks like you're trying to define a person which is defined in so and so Yang model, the person now needs a first name, and we set it as mandatory. So without giving that name, we will not proceed further. Okay, so that's about it. Then we cover the evaluate and application design considering latency and rate limiting in this group, which is the topic. No, we already have planned a list of topics. We'll be sticking to that. Because these questions will require a lot of background information to be. Yarn module is like a placeholder, right? It's like, let's say you have a huge like configuration settings that you are defining, like your BGP settings in one and ACL settings in one. So ideally, you will separate out all your BGP configuration into one module, your ACL configuration into other module, firewall settings into another module, so that you can keep those logical separation. On the other hand, let's say you just have a small device where everything related to that device are like just a few of the things, so that you will define just one module and put everything into that module. Right? So if you feel that you are trying to cram too many things into one module, then you start breaking that down into multiple modules. So module is just a logical separation. Roughly, you can think of it as like that. Yes. Yeah. Now, that import statement was there, right? You import a module. So tomorrow, if someone wants to import yours, they can use the name that you have given there. What approach you follow? You take one topic at a time. Try to gather as much information as possible for it till you are comfortable, at least to the extent of why that specific concept is used, where it is significant. Okay, others, I mean, we are done with the session. If, since we have some time left, we'll be taking question answers. So if you do not have any questions and you want to drop off, you can. You are free to do that. Otherwise, we'll just take questions. Yes, I'll be sending this reference guide.